So most of the functions we're going to study in this class will be given as some form of an equation. We're going to be dealing with equations. So how can we tell if an equation is a function or not? We've got example 9. We have this sort of one way of writing the equation of a line in general. Y equals mx plus b. You may be familiar with this form of the equation of a line. Example 10 says here's the equation of a circle, sort of in standard form, given that this circle has a radius r and is centered at the origin. That's the point 0, 0 on a Cartesian coordinate system. How can we tell if this is a function or if this is a function? So it's not necessarily obvious when we are looking at the equation itself, but if we look at its graph, it does become quite obvious. The tool that we are going to use to decide this is called the vertical line test. So when we're looking at a graph, if it's possible for a vertical line to cross the graph more than once, then that graph does not represent a function. So here is a line. And I'm just going to perform the vertical line test on this line. I will start drawing vertical lines to cut the graph. Oh, I only hit it once. 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 If it's the case that any vertical line I draw through this graph only hits the graph once, then this thing is a function. As it turns out, and you may have guessed this from looking at the title screen, or section 2.3, yeah, lines are indeed functions. Let's see an example that is not. So here we have a circle. The circle centered at the origin, like example 10. If I start drawing vertical lines, in fact, I hit the graph twice at any point I choose. Here, I will hit the graph twice. Here, I will hit the graph twice. This is not a function. Let's consider what's going on here. Why is this not a function? Why does the vertical line test work? But when we are reading a graph, the domain, here, the domain are all of the x values. Where the x values found, they're found on the horizontal axis. So everything on the horizontal axis is part of my domain. If I'm looking here, it looks like 9. It looks like my domain goes from positive 9 to negative 9. So I get all of these values. All of the x values between negative 9 and positive 9. That would be my domain. Everything along the horizontal axis that is covered by the graph. What is the range then? Well, the range will be the y values. So that's everything on the vertical axis. Here, on the vertical axis, everything that is covered by the graph. So we go from here to here. That also looks like negative 9 to positive 9. And that makes good sense because this is a circle. So we can come out here on our graph. Here to this point, x is equal to 5. I look up, I have a value here. This is the point x is equal to 5. And y is equal to something. I don't know what that is. I'll just call it a. But if I look down as well, notice when x is equal to 5, I have another value here. I'll just call it b. So this vertical line crossing the graph twice tells me that this particular x value, this x equals 5, gets mapped twice. It gets mapped to this y value up here, and it gets mapped to this y value down here. That is why it fails to be a function and why the vertical line test indicates that. All right, let's try out our vertical line test on this graph. This shape is called a parabola. You may have seen it in Algebra 1. Let's check if it is a function. Start cutting it with a relatively vertical line. Drawing straight lines is not my forte. And it looks like it's going to pass the vertical line test. I don't see anywhere where I could have a second crossing on this guy. So we do believe that this is a function because it passes the vertical line test. So yes, function should probably be green. The justification here being that it passes the vertical line test, VLT, pass the vertical line test. This must be a function. Let's decide what the domain and the range are. So come over here, we'll say domain. What's the domain? Well, it's everything on the x-axis that gets mapped. So we'll look along the horizontal axis. So we've got 0. Everything up to here. Looks like everything out this direction. Same in the negative direction, right? Everything out this way. And in fact, if we continue the graph zoomed out, if we zoom out, it looks like we will hit everything on the x-axis. So if that's the case, we say that the domain is all real numbers. If we hit everything on the x-axis, the domain is all real numbers. And in fact, we can indicate that with this fancy R. This fancy R means all real numbers. Let's find the range as well. Range will be everything on the vertical axis. So we will be looking on the vertical axis for the range. And notice that if we look in the up direction, in the positive direction, if we zoomed out and zoomed out and zoomed out, looks like we would hit everything. Looking down, notice there's nothing below this point that gets mapped to. So this is the low point here. It looks like about -3. So my range will be everything greater than or equal to -3. So all y values greater than or equal to -3 is my range. Notice if we turn a parabola on its side, what happens? Perform the vertical line test on this guy. And we hit the graph twice. We hit the graph twice, we hit the graph twice. So if we take a parabola and turn it on its side, it is no longer a function.